Hello, in the last video, I showed how to calculate range, maximum height, and the time for a projectile starting and ending with the same height. Today I would like to offer other types of problems often associated with projectile motion. So let's get started. If I have a cliff here, raised above the ground, if I have a projectile, and it's going horizontally off the cliff, and this cliff has a certain height, or we'll call it y. This projectile is going to have a certain range, or we can call this x if you want to. Okay, this has a certain velocity. All right, some things that we automatically assume that velocity along the y initially is equal to 0. Velocity along the x will be equal to the velocity because it all has an x component. We'll use this formula, height equals 1/2 gt squared. By using this formula, we can isolate the t to find the time. The time will be equal to the square root of 2 times the height, or y, divided by g for gravity. We also know the formula for the final velocity along the y-axis, the initial y plus g times t. And since this is 0 here, if we said it was 0, then I can say the velocity y final can be equal to g times t if I know time. All right, we're going to add some more components to this. For example, we often want to know what is the velocity vector when this object hits the ground. So if the velocity y final is on this axis, velocity x final is on this axis. And if I have my vector coming in like this, okay, this will be my final velocity. This angle will be theta as it approaches the ground. So we know then that the final velocity will be equal to, using Pythagorean theorem, velocity along the x final squared plus velocity along the y final squared, and also know that the angle in which it strikes the ground will be the arctan of the velocity y final divided by the velocity x final. Okay, this next scenario, we have the object being projected upward off of the cliff at an angle theta. So just a couple other changes we had to make. We know that velocity along the x is still equal to the velocity times the cosine of theta. This doesn't change throughout the entire motion. But I need another way of finding time now. So let me show you how to find time. We're going to say that y is equal to y sub o plus velocity y initial times time plus 1/2 gt squared. Okay, so what we can do is, if it hits the ground, that's going to be 0. So this is going to be the height, y sub o, plus v y sub o times t minus 4.9 t squared. And we'll just use a quadratic equation then to solve for t. I know that the final velocity y is going to equal the initial velocity y plus gt. And I can also use the final velocity y is equal to the square root of the initial velocity y squared plus 2 times g times the y value. For our first problem, my cliff is 6.5 meters. I have an object being projected directly horizontal at 3.5 meters per second. And it takes this path. So I want to know how far does it travel from the base of the cliff. In other words, I wanted to know the range. So we can say that velocity x is 3.5 meters per second. I can say that time is the square root of 2 times the height, which is 6.5, divided by gravity. That means it's going to take 1.15 seconds for this motion to take place. My x distance is equal to velocity along the x-axis times time. So there will be 3.5 meters per second times 1.15 seconds. So my distance traveled will be 4.03 meters. Okay, in this next problem, we have our cliff. I have a person up here. This person is going to be running in this direction at 1.8 meters per second. And they're going to go into the water. Suppose it takes 3 seconds for them to hit the water. What I want to know is how high was the cliff and how far from the base of the cliff did they hit the water. We know that y equals 1/2 gt squared. So y is going to equal 1/2 9.8 times 3 squared. So y is going to be 44.1 meters. So that's going to be the height. And how far from the base of the cliff? We can say that x is equal to the velocity along the x-axis times time. So x is going to equal 1.8 times 3. So x is going to equal 5.4 meters. In the next problem, the cliff is 45 meters high. We do not know the velocity, but it hits the water 24 meters from the base of the cliff. So what we want to know is find the velocity, so we need to find time first. So time is equal to the square root of 2y over g. So time is going to equal the square root of 2 times 45 over 9.8. So I know that the time is going to be 3.03 seconds. I know that x is equal to the velocity along the x-axis times time. I'm looking for velocity x, so velocity x is going to equal the displaced distance divided by time. So the velocity along the x is going to equal 24 divided by 3.03. So velocity along the x-axis is equal to 7.92 meters per second. For the next example problem, we have an 80-meter cliff. An object is propelled horizontally at 45 meters per second, and we want to find the velocity vector for when it strikes the ground. We know that velocity along the x-axis is going to equal 40 meters per second. We know the original velocity for the y-axis is 0. Time is going to equal the square root of 2 times 80 divided by 9.8. So that means that the time in the air is going to be 4.04 seconds. I'm going to use the formula velocity y final is equal to velocity y original plus gt. So this is going to be 0 plus 9.8 times 4.04. Okay, so my answer is going to be 39.60 meters per second. I'm going to give this a negative value because it's moving downward. All right, we know the horizontal velocity and we know the vertical velocity. So I know that my vertical velocity is going to be negative 39.60 meters per second. I know that my horizontal is going to be 40 meters per second. And here comes my incoming vector. So to find my velocity final, it's going to equal the square root of 40 squared plus negative 39.60 squared. So velocity final is going to be 56.3 meters per second. And my angle, -1 of my y, so which is the y is negative 39.60. My x is 40. So my angle here is negative 44.7 degrees, or I could say it's 44.7 degrees south of east, or I could say 360 minus 44.7, or 315.3 degrees. So this is my angle, and this is my velocity. And the reason the angle is this way, because we're in the fourth quadrant. For the next problem, I have a cliff that is 60 meters high, have an object propelled from the cliff at 40 meters per second at an angle of elevation of 30 degrees. Let's solve for x, or the range. Velocity x is equal to 40 times the cosine of 30. So velocity x is going to be 34.64 meters per second. Velocity y, initial will be 40 times the sine of 30 degrees. So that's going to be 20 meters per second. We need to solve for time. So I'm going to say that y equals y sub o plus velocity y original times time minus 4.9 times squared. So 0 equals 60 plus 20t minus 4.9t squared. Using the quadratic equation, I solve for t and I get 6.092 seconds. So now we can solve for x. So x equals velocity along the x-axis times t. So x is equal to 34.64 times 6.092. This gives me 211 meters from the base of the cliff. So that's my answer. In this problem, our cliff is 50 meters high. However, a projectile traveling at 7 meters per second at an angle of 53 degrees above the horizon. We want to find the velocity vector when it strikes the ground. So again, velocity along the x-axis is going to equal 7 times the cosine of 53. So that's going to give me 4.21 meters per second. Velocity y original is going to be 7 times the sine of 53. It's going to give me 5.59 meters per second. We need to find time. So y equals y sub o plus velocity along the y initial times time minus 4.9 t squared. So 0 equals 50 plus 5.59 t minus 4.9 t squared. So my time is, using the quadratic equation, 3.82 seconds. So my velocity y final is going to be the initial velocity y plus g times t. It's going to be 5.59 plus negative 9.8 times my time of 3.82 seconds. So my velocity y final is going to equal negative 31.8 meters per second. Okay, so that's supposed to be a right angle, by the way. This is negative 31.8, and x is 4.21. So my vector is coming in. So that my final velocity is equal to the square root of my x, which is 4.21 squared, plus my y, which is negative 31.8 squared. So now my final velocity will be equal to 32 meters per second. My angle is the arctan of my y velocity, which is negative 31.8, over my x, which is 4.21. So my angle here is negative 82.5 degrees, which is the same thing as 82.5 degrees south of east, 277.5 degrees. So I have my vector is 32 meters per second at 277.5 degrees. I hope you found this video helpful. Thank you for watching. Please like and subscribe, and I'll see you again soon. Thank you. Goodbye.